In this unit, we are going to learn about the properties of definite integral. In previous lesson, we always use a curve above the x-axis. Okay, so for example, here we can easily define what will be the area under the curve. So and this is, let's say, x, and this is y, and this is x. So we can define the area under the curve, okay, from a to b as integral. So the area, then area under the curve equal to then integral from a to b fx dx. So the question is, what will be the area if you have the curve below the x equals 0, below y equal to 0? So in this case, for example, we have here, so this is the x, this is the y axis, and let's say you have an a here and you have b. What will be, and let's say the total area here, we have defined it as the a area here equal to, let's say, 10. So what will be the area of integral from a to b fx dx? The answer will be negative 10. Okay, how can we imagine this one? Let's say we look into the first example about the velocity. Okay, from a reference point, the best way to understand this concept is by looking into example of velocity. Let's say we have a reference point here, and then we have a velocity, let's say a constant velocity of v equal to 3 meter per second. So what will be the distance as a function of time? So we then have curve of, okay, this is t and this is vt, in the unit is meter per second, and we have, let's say, this is the vt, this is the vt equal to 3 meter per second. And then if you are given, for example, what will be the total distance from time 1 to 4, so we can easily define it as the distance is s, normally s, then equal to integral from 1 to 4 vt dt, then that one equal to 3 times 3 equal to 9 meter. Okay, to understand what is the area under the curve below the y equal to 0 axis, we can look into, let's say we have a velocity, negative velocity. Negative velocity can be illustrated from this point. For example, here we have a vt equal to negative 2 meter per second. So if we draw this one in a graph, then you will have okay, this is vt, okay, the unit is meter per second, then we have here t axis, and vt equal to minus 2 is, this is minus 1, this is minus 2, so this is vt at time, let's say 1 to 4, at time 1 to 4, so this is 1 and this is 4. So the distance achieved is actually s equal to integral from 1 to 4 of vt dt equal to the area under the curve here is 4 times, so this is minus 2, so it's a minus 8. Why it's minus 8? Because basically it's backward, sorry, so the movement is backward, then you'll have the distance of negative. So we have learned that for the area under the curve of y equal to 0, the integral is negative. So here we have an example of find the area under the curve of gx dt. Okay, so we have, this is basically asking about what will be the area in between y equal to 0 over there. So I can it's -1, 2, -4. So this is -1, 2, -4. Okay, so basically it's the sum of all boxes. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 2 of half there. It's 10. So this is equal to minus 10 unit square. That's the area. We have another example here. I will give you an answer. So for the one on the left, find the area under the curve of hx from -1 to -5. Where is -1? -1 is here, and -5 is here. So basically, what will be the area under this? So we know that you can easily use, this is the half of a circle. So it's a half of a circle. So it's a half, area of the circle is pi r squared, and then we can have a half of pi. The the radius here, you can see it's 2, so it's 2 square. This one equal to a half pi 4, then it's equal to 2 pi. For the question on the right, function f is graphed as below. So find integral from 2 to 5. Oh, sorry, this one then, because it is, okay, this one is positive. So this is positive because it is above the t-axis in this case. So how about the one on the right? Find integral from 2 to 5. Where is the 2? 2 is this one. 5 is this one. So basically, what will be the area of here? First of all, we see this is below y equal to 0 graph. So the result must be negative. So it's a quarter of a circle. So the area then equal to negative is under the, because it's under the y equal to 0 axis, minus 1/4 of the pi time the radius square. The radius is from 2 to 5, that is 3 square, so it's equal to 1/4 pi 9 equal to minus 9 of 4 pi unit square.